Hello guys, in this video I will show you some standalone firmwares I worked on for with 𝐁𝐿𝐿. So different firmwares do different things. In this case, first of all I will show you the Mouthjacking one. Mouthjacking firmware is pretty much a search and attack autonomous firmware. So once you install on with 𝐁𝐿𝐿 will automatically scan for vulnerable mice or keyboards around vulnerable to Mouthjacking attack, of course. And then as soon as it finds one vulnerable device, it tries to attack it. Of course, what will inject the payload from attack.h array here. How to generate that? Well, is in the GitHub repo, in the standalone directory, in the directory of Mouthjacking. So just go and read the README. You need to run a Python script to generate whatever you want, and then place in the same directory of Mouthjacking firmware here. So now let's run it. Of course, this infers that you already seen the other video. You already installed all dependencies. Now you pick, as usual, LilyPad Arduino USB, the right port. In this case I connected already with 𝐁𝐿𝐿, and then you just need to upload the sketch. Here is in verbose mode Arduino, in a way that you can easily see what is happening. So here finally uploaded, and here is already starting to attack my vulnerable mouse. So okay, let me show you what is happening under the hood. So now it's scanning. Now I'm not moving the mouse, which is a vulnerable mouse, of course, to show you. So now you move. If I start to move it, soon should with 𝐁𝐿𝐿 pick it up, and picked it up, and voila, it injected the payload. By default, in the GitHub repo you will find that the attack.h payload is just a fake WannaCry. It runs on Windows, so just keep in mind, it's a joke. Now let's move to another one. Let's try Sniffle Replay. Sniffle Replay needs infers that you installed according to the schematics and the pinout two daughter boards, RX and TX daughter boards. Can be 433 megahertz, 315 megahertz, 868, whatever, simple daughter board you can find out there to transmit and receive packets. So again, same data here. So what it does, this one is the same firmware I used with the drone to show you the proof of concept about those RF blasting systems. So what it does is very simple. It sniffs the packet in the air in real time, and then it starts to repeat that packet and then brute force. So in my case now I have the balls fryer, which I showed in another proof of concept. So now I just turn it on. Well, actually it would be better if I would show you what is happening from RTL point of view. Okay, now let me recompile the sketch in a way that will stop the fuzzing sequence. Okay, as you can see here, nothing is happening now. So now we just, show you the serial monitor. Now I will press only one time the remote of the ball fryer, and you will see a peak here of just one single bunch of data. In the meanwhile, with 𝐁𝐿𝐿 is sniffing, and now it's trying to fuzz. As you can see here, it's fuzzing, and here we see flowing the packets from with 𝐁𝐿𝐿 daughter board TX. Right, which is approximately 433 megahertz. And this is how it's working, the standalone mode Sniffle Replay. So you just need to listen for one packet, and then we'll keep fuzzing for, depends on, how you design the algorithm. In this case, the fuzzy algorithm is very stupid. It's just a for loop, which is fuzzing the value, the decimal value of the first packet that was sniffed by with 𝐁𝐿𝐿. Next, let's see receive demo. Receive demo is simple. It's just receiving data. and decoding on the fly. So now we are compiling it. Give it time. Okay, so successfully compiled. We open again the serial monitor, and here is just a sniffer which decodes in real time the bit sequence and decimal value of that specific radio packet. So now again I'm pressing the ball flyer and it's decoding, you know, the vibration. This one instead is decoding the electroshock packet. Sometimes there might be some issues in decoding, but that's normal because, you know, but most of the time, as you can see, is always ending, you know, like with 20, the same packet. So it works. Another receive demo, this one. So if you want to play with, you know, replay some specific packets, like for example here, I was sending like, you know, the GSM alarm, the 453 megahertz packet to disarm, RFID lock to disarm the RF, to open the lock. This is some test I was doing for the crane. So here you just need to pick the right pin. In my case I used the pin 11. You can use either pin 11 or pin 7 to transmit, and P3 D3 to receive. So in this case, this is the sequence will be sent. It will be sent on pin 3 and will be transmitted 3 times, and then of course there is a loop, so every 2 seconds will be transmitted this sequence. Now let's see. Compiling. Okay, let's turn on. As you can see, here is that packet. So here in real time we are sniffing with the RTL SDR to show you what is happening on the air. As you can see, every 2 seconds is sending this bit sequence. So every 2 seconds is sending this bit sequence 5 times in a row, and then every 2 seconds is repeating that. As you can see, very precise. So that's it. Of course, this infers that you know what you're doing. You can even create your own pulses or change the protocol, because 𝐂𝐶 has different encoding protocols. Always, you know, ASK modulation, but still you can change the encoding, or you can create even your own pulse type by, you know, defining the length of the pulse. So just look at the 𝐂𝐶_𝐍𝐶, which is on GitHub, and that should be fine. I guess everything is clear. If not, try to open issues, but you know, keep in mind I have no time for those, so be smart. This is a hacking tool. Infers that you have some knowledge of, you know, electronics, programming, radio waves. So just don't think you can open an issue and wait for me to reply like that. Most of the time I would close the issue without even thinking to even answer. So just keep that in mind. Bye.